Let us continue to consider area under a curve and its meaning in relationship to other things with the function v of x equals x squared plus 1, which is a velocity function. And if we graph that function, the x-axis will be time in seconds. We've got values 1, 2, 3, and 4. The y-axis would be feet per second, going by units of 4, and so we plotted some points. And as we've discussed before, the area under this curve, between the curve and the x-axis, would represent total distance traveled. Per second. This area under the curve that I'd like to know something about. And one of the problems is coming up with that, because this is a curve as opposed to something like a horizontal line where it's easy to come up with a rectangle. But I'm going to use the idea of rectangles to construct this. And I'm going to do this, in this case, is with what's called a left line. It's a left Riemann sum because all of my rectangles that I sketch in, that will be 1 unit wide, will be touching the curve on the left-hand side. A right Riemann sum touches the curve on the right-hand side. And a midpoint Riemann sum touches the curve in the middle. I've broken this curve up into 4 rectangles. The first rectangle has a width of 1 and a height of 1. The second rectangle has a width of 1 and a height of 2. The third rectangle has a width of 1 and it has a height of 5. And finally, a width of 1 and a height of 10. So these are the area of each of these 4 rectangles, with the height coming, say, of the third rectangle. I plug 2 in, I get 4 plus 1, which is 5. Here when I plug 3 in, I get 9 plus 1, which is 10. Which means that the total area of all of these rectangles is 19. And this 19, in our context, would represent the number of feet traveled by this object in the first 4 seconds.